Welcome back to our continuing coverage on the preliminary report, the 15-page report of the Aircraft Accident Investigation Board that has now been submitted to the Ministry of Civil Aviation. It's up on their website, and it gives us some preliminary clues, some answers as to why Air India Flight 171 from Ahmedabad to London Gatwick crashed. And it is going in the direction of the fuel control switch. Those two switches that you see, they're called the fuel control switch. They are the ones that allow the movement of the fuel from the fuel chamber, from the fuel tank, out into the carburetor, and from the carburetor into the engines. The engines require the fuel to be fired up and to give the aircraft lift and thrust and power. That fuel control switch was moved from run to cutoff and then back again from cutoff to run after the pilots realized that the fuel had been cut off from entering the engines. So the 787 fuel control switches, like I said, there are only two modes there, and it has to be manually done. There's a run mode if the switches are in the up position, and there is a cutoff mode if the switches are in the down position. Now these switches are controlled only either at the start of the flight or after the flight has ended. Now it is not ever moved mid-flight. Something happened inside the cockpit of Air India Flight 171, which resulted in these fuel control switches being moved from the run mode to the cutoff mode, and as a result, immediately the flight lost thrust, it lost power. Now, this is not an easy thing to do. It cannot be done electronically, it cannot be done remotely, it cannot be done by somebody from outside the cockpit. It has happened inside the cockpit because there is a metal stop lock. Now, what you need to do is you have to manually pull both the levers. It has to cross over that metal lock switch and then be placed either down or up. There are also these two metal brackets. They're called the guarded brackets, which are on either side because in case, one captain's hand or the other co-pilot's hand hits these levers, that they don't accidentally move either up or down. So it's an extremely well-designed mechanism, and clearly on board Air India Flight 171, something happened whereby manually the cutoff switches were moved from run to cutoff. The pilots realized that. One pilot asks the other, it's not identified in the report which pilot asked the other, but one pilot asks the other, why did you cut off the switches? Why did you cut off the fuel? And the other pilot replies, no, I did not. Now, we don't know which pilot asked which pilot this question and what the answer was, but we know that one pilot certainly asked the question, why did you cut off the fuel cutoff switches? And the other pilot replies, no, I did not. Let's try and find out more about this. What are these fuel cutoff switches? It has to be operated manually. It cannot be operated electronically. Could there be any kind of mechanical failure, electrical failure that leads to these switches to be snapped? Or has it necessarily have to happen by manual action by either the pilot or the co-pilot? Arunima is here with us. She's been tracking the story ever since the crash happened on the 12th of June. Today, incidentally, is exactly 1 month since that. Tell us what this preliminary finding says about why these fuel control switches moved from run to cutoff. Okay,
so the report is not conclusive. It is not reaching any conclusion, and hence the confusion. However, it is pointing out two things. One, that engine lost power, and that was the likely cause for the crash. So all the other theories that we had considered so far, bird hit, that has been negated, fuel contamination, that has been negated, weather condition, that has been negated as well. So if we finally know why the crash happened, it is because fuel was cut off to the engine. Why was the fuel cut off? To that, the answer in this preliminary report is that the fuel control switch went from the cutoff mode to the run mode, and the movement from cutoff, why it was cut off, we don't know. But the pilots, it appeared, tried to put it on the run mode, but the time was not enough, even though one of the engines tried to gain power, but the timing of the entire crash, the timeline is such that it looks like there was not enough time available for the engine to restart. The big question which is unanswered in this report is, how did the fuel switch, and we are showing you on air as well, there are two switches. How do they work? Can you just mistakenly land your hand or your palm on it and it can operate? No, that's what experts tell us. There's a spring, you have to physically lift it up and then move it from cutoff to run, and you can mistakenly do it with one of the two levers, but how is it that fuel was cut off to both the engines? That's a big question that has been left unanswered. Also, if this was a mechanical failure, then towards the conclusion of this report, what the AAIB says is that at this stage, neither GE, which is the engine manufacturer, nor Boeing have been asked to carry on any further tests or checks about mechanical failure. That makes it even more intriguing about what really happened with these fuel control switches.
So let's also bring in our guests. So we know a couple of things. The AAIB preliminary report is suggesting that the fuel control switch was in the cutoff mode. It should have been in the run mode. The pilots realize this and then they move it back into the run mode. But because the aircraft had not got enough liftoff, it had not got enough aerial sort of altitude. If it was 1,000 feet up, then this would not have been a problem. But it was barely, I mean, the maximum height it reached was about 625 feet. So because of that, there wasn't enough time for the fuel supply to go back into the engines. I believe one of the engines then restarts. It's relit, but the second engine is not. The RAT gets deployed. The RAT is the Ram Aviation Turbine, which is a Boeing 787 mechanism whereby if there is a dual engine failure, there is this propeller, and you can hear the noise from those videos that came out on the first day. You can hear the noise of the RAT. You can see the RAT being deployed to try and give you enough electrical power and hydraulic sort of movements inside the cockpit so that the captain and the co-pilot can then find a place to safely land the aircraft. Now, let's go across to Air Marshal Retired Sanjeev Kapoor, former DG Inspection and Safety of the Indian Air Force. KVG Rao is former cabin crew of the Air India. Mark T. Martin is CEO of Martin Consulting and an aviation expert. I want to go across to Air Marshal Sanjeev Kapoor. So I just want to be very clear. So the preliminary report says that the fuel control switch was in the cutoff position by the time the pilots realized and moved it back to run. There wasn't enough time, there wasn't enough altitude for both engines to get the fuel. Can this happen because of mechanical fault or electrical fault, or can this happen remotely? Can somebody from outside the cockpit do this, or does this 100% have to have been done manually by either the pilot or the co-pilot?
Let's break it down. Okay, no doubt that both the engines failed.
Yes.
Because, so that's very clear. Now, let's break it down. Why would pilot give a mayday call if he is himself switching off this? He has given a mayday call. It means there is some grave emergency which he has seen to, endanger everybody, and that's how. And it's very, very rare in a civil aviation. Air Force aircraft, we do have a lot of situations. It is at that speed and altitude. But in a civil aviation aeroplane, immediately after getting airborne, give a mayday call by the pilot is the first indication that something very serious has happened. So in my appreciation, having seen and heard and read whatever, I just tweeted the manual page of 787, which says in case of both engine failures, the crew manual, the air crew manual says of 787 that the fuel control switches, the first action is to recycle the fuel control switches. So in my appreciation, there is a loss of power. And as the action takes, both are seasoned pilots, and there is no, I was speaking to Anand a little while ago, that there is no action in a multi-crew cockpit which one person can do by himself or herself.
Okay.
It is always challenge and response. So one pilot will say, moving the fuel control cutoff switch to off. The other one will say, okay. And he looks, it is not that, and this is not run-of-mill switch with one flick it goes down.
Yeah.
These are power-loaded, spring-loaded switches in latches. So these have to be physically moved out of the gate, lifted and brought down. It is not inadvertent touching. So the crew would have tried to relight the engine in my appreciation, and that's how this switch moment has been recorded. Now, why did the engines fail is the question in my appreciation, which didn't come out very clearly in this report. Engines failed.
Let me ask Mark Martin, who's the CEO of Martin Consulting and Aviation Expert. Mr. Martin, so from this 15-page report, what we do know is that the fuel control switches were in cutoff position. They should have been in run position. The pilots realize it, and they pull both back into the run position. One of the engines gets relit. The second one did not have enough time to get relit. And of course, the RAT had already been deployed, and the plane crashes. But the question is, does this necessarily have to be done manually? Why did they do that? Why was it in cutoff in the first place? How come no one noticed it? Or were they moving it from run to cutoff and from cutoff back to run because it was a dual engine failure? And as Air Marshal said a moment ago, that is the aircrew manual for when there is a double engine failure.
Let's understand the facts behind this. Okay, first up, you're at 180 knots. You're 800 feet, you had your takeoff thrust, you lost both engines. Now, when you lose both engines, then that's far more significant than cutting off your fuel. Your fuel cutoff valve, the switch which is there, you got to pick it up, put it over the bridge, and then put it down. Okay. Now, there's no chance in hell that the fuel cutoff switch is going to automatically trigger unless there was severe vibration on the aircraft that triggered something to push it back. Now, let me be very, very clear over here. This is a digital aircraft. The whole aircraft is computer controlled. It's software controlled. It's got something called LSAP, loadable software as a part. Every part of what you see in that aircraft in the 787 is controlled by a software system and a server. Now, the first question of mystery I have here is that, first of all, no pilot would be stupid or dumb enough during takeoff, when his attention is focused forward on the flight instruments. He still is flying a manual. He's hand flying it. He hasn't activated the auto throttle. Autopilot is not engaged. He's climbing at 800 to 1,000 feet. He's still flying manually. There's no chance in hell your hands are going to go back and fiddle around with the fuel cutoff. Something is wrong with the fuel cutoff. Now, if you read the same report, if you've seen the pages before and not gone to why the crash happened, in 2018, Boeing issued a service bulletin stating that there have been incidents where the fuel cutoff valve has gone back to cut off from run. This was the part number. This part number is constant in the 737 and the 787. It's the same part, guys. Let me be clear.
Sorry, Mr. Mark, I'm going to interrupt you. Just give me 1 second because we have to take a break. That's mentioned in this AAIB report as well. This 2018 advisory was a non-mandatory advisory from FAA, the Federal Aviation Administration, to all airliners. It was a non-mandatory one. That's been cited in this report as well. We'll talk about that in just a moment on the other side of this quick break. Welcome to our continuing coverage here of the preliminary finding of the Aircraft Accident Investigation Board, the AAIB, which was constituted under the Ministry of Civil Aviation. It has released a 15-page report which goes into what caused the crash of Air India Flight 171 from Ahmedabad to London Gatwick on the 12th of June. Today is exactly 30 days, a month since that fatal crash in which 241 out of 242 passengers died. Let's bring you up to speed with what the findings of the Aircraft Investigation Board are. Remember, the flight reached about 600 odd feet. Number one, both engines shut mid-air. This is what we've all been talking about for the last 1 month. It was a dual engine failure. The report attests that both engines had failed. Why did they fail? It also shows that at one point, before the 30th second, at one point, engine 1 gets relit. Fuel had been cut off to both engines. We'll get to that in 1 second, why that fuel was cut off. Engine 2 was also relit, but it failed to stabilize. It was not able to generate enough power for giving the aircraft enough lift and thrust to move up. It had reached only 600 feet. Number 4, and this is the most important point, the fuel cutoff switches were activated mid-flight. The pilots realized the fuel cutoff switches, which had to be on run, was on cutoff. They realized that, and then they moved the switches back from cutoff back to run. The cockpit voice recording also indicates one pilot, we don't know who, one pilot asking the other pilot, why did you cut off the fuel switches? To which the other pilot responds, no, I did not. Like I said, we don't know which pilot is asking which pilot this question, but this was certainly asked by one pilot to another. We also know that it was the junior pilot, the co-pilot, who was the pilot flying, and it was the senior pilot who was the pilot monitoring. No conclusive evidence of how the fuel cutoff switch, which should have been on run, wasn't cut off in the first place. And number 7, both engines dropped below the idle speed, and that's why they were not able to generate enough power to keep the aircraft going. The flight data recorder was also damaged to try and get enough data to find out what exactly led to this crash. Both pilots were well rested. They were fit to fly. They were both experienced. Between the two of them, remember, they had 10,000 hours of flying between Captain Sabharwal and co-pilot Kundar. They had 10,000 hours of flying. The investigation will now examine additional evidence. The preliminary report, it's a 15-page report. It's now been submitted to the Ministry of Civil Aviation. The investigation will also examine if there is any additional evidence that is brought forth. The preliminary report simply says that their finding is that the fuel cutoff switches, which should have been in the run mode, were in the cutoff mode. The pilots realized this, and then they move it back up to the run mode. But because the flight had not got enough elevation, it had not got enough altitude, therefore it didn't have enough time to reignite both the engines and thereby produce enough power and thrust to try and keep the flight going. Let's bring you up to speed with more findings. Questions are being asked about how did this happen. Remember, this has to be manually done. This is not an electronic procedure. You cannot do this remotely either. The fuel is drawn from the fuel tanks. There are pressure pumps through which the fuel is then injected into the carburetor and from the carburetor into the engines, and then the fuel pump fires up the engines. The fuel passes via the fuel filters, which remove any kind of impurity. Remember, this investigation has also checked out the fuel from the Bowsers. It has examined the fuel and it has said there was no contamination in the fuel. The control unit then regulates the flow of the fuel, how much fuel at what speed goes into the engine and fires up the engine. The fuel and air is mixed. It's a combination. It's a combustible combination before it's delivered to the cylinders of the engine, which then are powered up. The fuel-air mixture produces power for the aircraft to fly. At some point in this flight, and remember, this whole thing happened in just 30 seconds. This whole thing concluded in 30 seconds. At some point, the pilots realized fuel was not flowing from the tank into the engine, and that was because the fuel cutoff switch, which should have been in the run mode, was in the cutoff mode, and then they realized that, they move it back into the run mode, but they didn't have enough time. They didn't have enough time for the engines to be relit, both the engines to be relit and to continue the flight. So the big questions that we're asking, basis this preliminary investigation by the Aircraft Accident Investigation Board. Number 1, there is clear confusion between the pilot and the co-pilot. One pilot is asking the other, why did you cut off the fuel switches? The other pilot replies to it by saying, no, I did not. Number 2, how was the fuel switch, the fuel cutoff switch, why was it in the cutoff position? It should have been in the run position. Remember, there are only 2 instances where this switch is manually handled. One on the ground before takeoff and the other after it lands, after landing. Why mid-flight was this moved from run to cutoff and then back from cutoff back to run again? system failure? Was there, one of the guests earlier was saying that there could have been an LSAT or a system failure that led to this fuel cutoff. We'll have to explore that. Did Boeing or Air India ignore any FAA advisories? There was an FAA advisory back in 2018. It was a non-mandatory advisory, but it certainly did say that there was some faulty mechanism which automatically led to this fuel cutoff, and that airliners should pay heed, pay attention to this. It was, like I said, it was non-mandatory on the airliners. Number 5, what additional proof will the Aircraft Accident Investigation Board examine to try and come to the exact conclusion as to why Air India Flight 171 crashed? For now, what the report says is that the fuel cutoff switch, which had to be in run position, was in cutoff position, and the pilot and the co-pilot realized this by the 4th or 5th second after takeoff, and then right after that they move it back into the run position. By the time they move it back to the run position, there wasn't enough elevation on the flight, there wasn't enough altitude on the flight, there wasn't enough power on the flight for both the engines to be relit and for the flight to continue. Arunima is here in our studios. Anvit tracks the Ministry of Civil Aviation for us. Arunima, of course, was tracking this right from day one on June the 12th when the air crash happened just off the perimeter wall of the Ahmedabad Airport. Arunima, explain this in simple language for our viewers. What is this fuel cutoff switch? Why was it in the cutoff position? And can this be done remotely, electronically, by somebody outside the cockpit, or does this necessarily have to have manual intervention?
So the fuel cutoff switch are 2 switches which are aided by springs. Maybe we can pull out that picture which we have and put it on air to show to our viewers as well. There are 2 switches. If you take them up, it means you are in the run position, and if you are keeping them stable, which means that fuel supply is continuing. In this case, it looks like what AAIB has found out, that there was the fuel switches taken. These are the 2 switches taken to the cutoff position. You see cutoff written below that, so it has been taken to the cutoff position. Taking it to the cutoff position means that engine is no longer getting any fuel, which means loss of power, loss of thrust, and preliminary report seems to suggest that this is the reason why this aircraft crashed. Now, was this problem with the switch right from the start? I just want to go through the timeline that has been given in the AAIB report. At 7:56, and this is all UTC time that is being given, the taxiing of the aircraft begins. At 8:07, the aircraft is rolling. By 8:08, 42 seconds past that, it has hit the maximum speed limit, which means that till this point the engine has enough power, which makes me conclude that the fuel switch is in its fine position, it's in the run position, and fuel is still going to the engine. What happened then suddenly at 8:08:56? This is when pilots realize that there's something wrong, and
But 8:08:56 is after takeoff. They've
after
taken
takeoff,
off.
yes. 8:08:42 is when the maximum speed has been achieved, and which means they have taken off. It's at some point between this 42 and 56 that they realize that it has to be taken to the run position. The switch is in cutoff position. At 8:08:56, the second engine's fuel switch is also moved to the run position. But by then, I think the damage is already done, because relitting takes time. The engines take time after they have been cut off to once again get their power. At 8:09, 5 seconds past that fraction of second, the mayday call has been given, and at 8:09:11, the EAFR has stopped recording, which means it is at this point that the flight has crashed. So something has happened between 8:08:42 when the maximum speed was achieved, and 8:09 past, and 11 seconds past that.
And I just want to be clear for our viewers, this cannot be done remotely, this cannot be done electronically, this has to be done manually, where the fuel control switches are moved from cutoff to run or run to cutoff.
Yes, and if this was a mechanical failure, then what the final page of this report says. It's a 15-page report. In the final page, it says that GE, which is the engine manufacturer, and Boeing, which owned the Dreamliner, none of them have been asked to carry out any further investigation for mechanical issues. So if a mechanical issue was found in this entire probe as to why did it come to the cutoff position, ideally GE or Boeing would have been asked to carry out some tests, but that has not happened. So it's a big mystery as to how this happened, that these 2 critical switches went into the cutoff mode.
Let me go across to Anvit Srivastava as well before we go to our guests. Anvit, where's the minister? Where are the members of the Aircraft Accident Investigation Board? They were assisted, of course, by the NTSB, by the FAA, by representatives from Boeing and Air India. I believe both Boeing and Air India have put out statements initially after this report was made public. What is the latest that you have?
Yeah, Zaka, the minister has been travelling and we tried to re-establish contact with him, and his team had said that he will be talking to us later. And there are also statements from other stakeholders, be it Air India and Boeing, and they've all said that they have assisted in the investigation, and they'll be continuing to do so. But at this stage in investigation, these are the preliminary findings that have been put out by the AAIB. But all the stakeholders are still in contact with AAIB because a detailed report will follow. Now, these are the preliminary findings which hint towards the main focus of the investigation being the fuel engine fuel switches. But see, some details that this report has raised some questions as to that, because see, we have previously seen that RAT was also deployed, and the time has also been mentioned at what time was the RAT deployed, the ram air turbine. But we need to understand also that whether how much fuel was in the engines to allowing it to take off, and then RAT deploys, and then the fuel supply is cut off, leading the plane to plunge and to not allowing it to rise in altitude. So these are the details that we are looking forward to as the detailed report will come out. Also, the investigators have focused on the switch, talking about how the pilots had had a conversation between them, but it is not mentioned as to which pilot is speaking to which pilot, whether it was the pilot in command who was holding the flight in control at that point in time, or was it the first officer. So those details are also yet to follow, but it is clear that the fuel supply of the engines were cut off, and that is the reason that had led to this crash. But some more details will also emerge, as they have gone on to say that at this time no recommendations have been made to the engine manufacturer or to the aircraft owners. But in time to come, yes, certainly when the detailed report comes out and more details are found as to what led to this exact cutting off the power and the transitioning from run to cut off, and then attempts were made by the pilot to bring it and reignite the engines. But since like Arunima mentioned, the altitude was not enough to make and to allow that time to the pilots. So those details, we are awaiting those details, and we are expecting that the detailed report that the AAIB will put on, and which also will be shared with the ICAO, that will certainly clear these doubts.
All right, Anvit, we'll leave it at that. Thank you very much. We'll come back to you as and when there are further updates. I believe the minister is traveling to his constituency. We have a reporter there as well. We will also be tracking the Civil Aviation MOS, who is in Pune, so we have a reporter there as well. So the moment they make any comments, we will bring it to you. Let's also go across to our guests. Air Marshal Retired Sanjeev Kapoor is former DG Inspection and Safety of the Indian Air Force. KVJ Rao is former cabin crew of Air India. Mark D. Martin is CEO of Martin Consulting. Mr. Martin, I'm sorry I had to cut you off in the last wheel, but the sequence of events after takeoff, 0 seconds, the takeoff happens, the aircraft lifts off. 3 seconds after takeoff, which Arunima was also referring to, at 8:08:42 is when it hits the maximum speed of 180 knots. 4 seconds after takeoff, engine 1's fuel switch is cut off. 5 seconds after takeoff, engine 2 fuel switch is cut off. 8 seconds after takeoff, the RAT is deployed, because the RAT is a mechanism in the Boeing 787 which gets deployed when there's a dual engine failure. So within 10 seconds of takeoff, both pilots realize that there is a dual engine failure. 13 seconds after takeoff, they try to push it back from cutoff position to run position, the fuel control switches. This is for engine 1, and then 17 seconds after takeoff, they try to push the second engine, the second fuel control switch, from cutoff to run. But because, as everybody has been saying, this flight hadn't got enough lift, hadn't got enough power, it just sort of papers off and then crashes outside the perimeter wall. What are the questions that stand out for you, Mr. Martin, after this preliminary report?
So Zaka, it's almost deja vu. I remember 15 years ago, you and I were talking about Air India Mangalore crash when you were over at Headlines Today. So I'm just going to fast forward. The RAT only gets deployed when you have a total failure and an emergency situation. It's an auto logic in the 787, on the 320, on all aircraft. Now, if the RAT is deployed, RAT never deploys if the switches have gone over to cutoff. Okay, switches going over to cutoff does not mean RAT deploys. RAT deploys because it's an auto sensor that everything is failed on board. That's the first thing. So the word is engine failure. And if engine failure occurred, dual engine failure, then the rat deploys. That's the first fact on this whole thing. The second is assuming that the fuel cutoff switches had a problem, assuming many a times, Zaka, I'll tell you, OEMs issue a service bulletin, not a advisory circular or not an AD, because they just want to keep it subtle and just inform everybody, and they pass the responsibility back onto the airline and the operator. Now, if the fuel cutoff switches went bad, and even if you turn it back and you turned it on, there's no chance you're going to get the kind of takeoff thrust in 3 seconds. You're at 800 feet, you're dropping like a rock, 180 knots, your speed is reducing, all your attention is in your forward cockpit instruments. There's absolutely no way your hand would ever go back. That's the second part I'm going to say. The third part is that even if you had an engine failure, and let's assume the procedure was to recycle the fuel switch, the fuel valve, that even in that it takes almost 3 to 4 minutes to start again. So the first point we need to understand, and we need to be very, very clear, is that this is an initial report.
Correct.
There's a lot more work that needs to be done. No stone should be left unturned, Zaka, and I'll tell you why. Because why on earth would a mechanical switch go from manual, run to cutoff? Now, I got to be clear, as an investigator, and I'm sure everybody on your panel, including Air Marshal, will say this, when a rat gets deployed, there's extreme vibration on board the aircraft. I don't know if it's happened to me. A rat gets deployed and there's vibration. Now, my logical understanding as an aviation guy and a pilot would suggest that vibration let the engine switches to go, because it's obviously a wear and tear mechanical device. Now, granted, there was an AD, there was an SP which came out in 2018 that warned everybody to inspect it. Maybe they did not inspect it. Maybe they should have changed it, replaced it. We don't know. But if a mechanical switch with a spring, you could actually got to pick it up and put it into place. It's a gate, and in that, if it went back, then clearly it could either be because of extreme vibration, or something which is triggered, or that mechanism has been overused, or the metal frame or the gate has been worn out. These are the 3 or 4 plausible reasons. But again, guys, Zaka, you and I have spoken about crashes, sadly, nearly 4 or 5 times in the last 15 years, right? And my request is, let that full investigation get out, because now, let's not speculate. We can come up to our own theories, which is good. And I think, this is not a pilot issue, because why on earth would the pilot pull the switches back at 800 feet and kill himself and kill 260 people on board? Okay. Something has triggered that. And as you guys have rightly pointed out, that is the crucial bit. And we need to go back and ask why. And that's what will establish.
That's a fair point. Like I said, this whole exercise is not about finger pointing or blaming someone or blaming the pilot and the co-pilot. No, I mean, something went abysmally wrong on board Air India Flight 171. We have to find out what that was. And this preliminary report is just a 15-page report. And these final reports take probably years. I remember the 2020 air crash that happened in Kozhikode. It took a whole year for it.
I remember it took almost 4 years. Remember, Zaka? Exactly. We spoke about it in June 2010. It took 4 years to get out.
For it to come, yeah. Arunima wants to make a point on this.
Just one point. This point about vibration, that possibly some vibration happened. On that point alone, let's bring in what the sole survivor of the air crash has told investigators. The sequence of event, as he describes it, is that the flight takes off and suddenly he says it feels like it has gone in a limbo. It's not moving forward, it's not going back, and then the lights come off, and then suddenly the aircraft accelerates and then it drops dead. The crash happens. So at no point is he mentioning any kind of vibration or any external factor that he could take note of which could have led to this kind of a situation.
Also, I mean, one basic question is, if there was, as you said, some vibration that led to automatically the switch going from run to cut off, and the pilots, by the time they realized it was too late, wouldn't this report also say that we've asked GE, the engine manufacturer, we've asked Boeing, the manufacturer of the aircraft, to look into this possibility?
So the flight data recorder data is binary, Zaka. It just shows 0 or 1.
Okay.
1 is on, 0 is off, or it might show 2, 3 as part of a setting. It's digital. And this DFDR is one of the most advanced in the world because the 787 also has a cockpit camera. Okay, so a cockpit camera is installed on a 787, and that cockpit camera records all action. So it's a surprise to me as to why did the advanced enhanced airborne flight recorder, why doesn't the report talk about the cockpit camera footage? Where is the cockpit camera footage? Because that will reveal everything. This aircraft has got a cockpit camera which focuses on the cockpit. It's got a galley camera. It's got a left camera which also captures pilot actions. It's an advanced flight data recorder. And my question is, we want to see that video footage of the cockpit camera because that will tell us precisely what happened. Also, we have to be very clear that from time of takeoff, we're just talking about 20 seconds to crash.
Correct.
At 20 seconds to crash, these are micro steps and milestones which have occurred in this incident. RAT will only deploy when you've lost everything: hydraulics, pneumatics, engine, electrical power, all gone. That's your last resort. You're flying on something called an essential power bus, which, Zaka, is a battery that sits below your chair, your seat, and your hydraulic electrical power from the RAT. That's it. Everything has failed. You're down to the last straw. Now, in that situation, if somebody looked back and saw that the switches were, first up, ask me honestly, there's no chance in hell the switches can go back miraculously or by, divine intervention. Okay. And second of all, if it went back, then there's something wrong with the switches and that mechanical device. Maybe it's worn out and no maintenance guy from Air India chose to even bother to check it. And the third is
Mr.
RAT deploying is the biggest evidence.
Well, I want to shift focus again back to these fuel control switches. What are these switches? What do they do? And why are they critical, at least as per the initial findings of the Aircraft Accident Investigation Board? Now, the fuel control switches, there are two. They control the flow of the fuel, the aviation turbine fuel, from the fuel tank through the chambers into the engine. And then, of course, the engine, the fuel powers the engine to get lift and power and thrust. So these are basically, on the cockpit. It's right next to both the pilot and the co-pilot. There are two separately for both the engines. When they're placed down, they are in the cutoff position. When they're placed down, you can see cutoff written here. So if they're placed down, they're in the cutoff position, which means that it is restricting the flow of fuel from the tank into the engine. This, remember, there is this sort of metal constrictor. This metal constrictor that you can see, this whole gear itself is spring-loaded. There is a spring that is attached to this. So basically what the pilot or the co-pilot, as the case may be, pilot flying or pilot monitoring, will have to lift this because it's spring-loaded. He has to lift this and then move it past this metal constrictor, move it past to the run position. Similar, when you do the opposite action, from run to cutoff, you have to lift this flap, take it over this metal constrictor, and then put it down to cutoff. It's a manual action. You have to lift, pull up or pull down, and then release. That's how it's done. And it cannot be done, like I said, either electronically, it cannot be done remotely, it cannot be done by anyone outside the cockpit. It's purely manual action. Now, here what happened is, and mind you, in most flights, and we'll have, we'll go across to Air Marshal Sanjeev Kapoor as well. In most flights, this switch is never touched. It's only touched twice, either at the time of takeoff or before takeoff, or it is touched after landing. At no point through the course of the flight are these switches touched because if they're touched, then it cuts off the fuel supply into the engine, thereby the engine then loses power. Let me ask Air Marshal Kapoor this. I mean, this is what the report says. The report says that at the fourth second or the fifth second after takeoff, the pilots realize that the switch, the fuel control switch, was in the cutoff position. What can plausibly explain that? Because if it was in the cutoff position, how did it get power to taxi all the way and to take off? I mean, you need the fuel to go into the engines for that duration, about 14-15 seconds it took for the taxiing and for it to take off. And then suddenly the fourth or fifth second after takeoff, they realize that the fuel control switch is in the cutoff position.
Yeah, whatever aviation sense and knowledge I have, and having read and seen this accident, and I have handled a large number of accident investigations in Air Force. And Air Force is the only agency in this country which conducts a regulated accident investigation course in which the civil aviation people also come and learn from us. Now, coming specifically to your question, there was a similar incident on 787 in Nippon Airways in Japan in 2019, January, when after landing 787 Dreamliners, when the pilots operated the thrust reversals, both the engines got cut off. Now, this is recorded. The aircraft had fortunately landed, it rolled, and thereafter it was towed outside. They did a lot of research. So 2019 onwards, 2018, there's an FAA advisory. Yeah. 2019 on similar, the engines, both the engines just cut off in 2019 in Japanese Nippon Airways. Now, coming specifically to this accident, in my appreciation, it is not possible that before takeoff or during any condition, the fuel valves would have been shut, because the aircraft would not be generating that kind of thrust and power for it to get airborne. Now, it is a hot afternoon 1:30 or 2 local time. Temperatures must be, tarmac temperatures must be around 45 plus degrees centigrade. The aircraft is fully loaded, 100 plus, 105, 10 tons of fuel with full load of passengers. The pilots would be busy flying and looking ahead, because Ahmedabad is a runway with a lot of bird activity, and generally having flown there, you're always on your edge to see where the takeoff path and the funnel is clear. Now, at this stage, something has happened at unstick. The most important, Zaka, in my appreciation, in what piece we are missing out is the pilot has given a mayday call. Why would a pilot give a mayday call at unstick? It means he has experienced loss of thrust on both the engines. This one engine itself is capable of taking this aircraft up and away. So he has lost both the engines, and the 787 manual, I just tweeted this morning, indicates very clearly in case you have 2 engine failures, which generally happens when you fly over volcanic ash or other conditions, because 2 engine failure on a 2 engine aircraft is extreme rarity. And the pilots are only made to do this exercise in a simulator in 1 in a million case when both the engine fails in an airline and of this high-tech platform.
Okay.
Zaka, can I step in? Can I say something?
Just 1 second. I have to take a break. Captain Ross Eimer is also joining us as a retired United Airlines pilot. We'll go across to all our guests in just 1 second. But just on the meteorological question that Marshal Kapoor raised, this is there in the AAIB's report, the preliminary report. Point number 8 is meteorological information. It says at 7:30, it was at 36 degrees, not significant. At 0800, it is at 37 degrees, again not significant. 0830, it is again at 37 degrees, not significant. 0900, it is at 38 degrees, it says not significant. That's what the report says. Now, whether or not that was a reason, we don't know, but the report says that the meteorological activity, the heat or the climate activity, was not a significant factor that led to the crash. Let me take a quick break. When we come back, we'll continue a conversation on the preliminary report of the Aircraft Accident Investigation Board, which looked into what caused the crash of Air India 171.